Okay, my name is Srinivas and I'm OBIEE online trainer, and I'm going to give you a workshop on this OBIEE. Okay, as part of this workshop, first I would like to give you some overview on OBIEE. What is this OBIEE and what we do with this tool? Actually, OBIEE is Oracle product, and it is Oracle Business Intelligence Enterprise Edition. Is a reporting tool, and it will allow the customers to analyze their business in a uh, in a way that they can able to take the best decision by analyzing different areas or different components in their business. Just like in a different dimensionality, they can able to do the using this OBA, and they can able to take a best decision. Like if they want to do the analysis on the reports, like on a day wise or on a time specific, like year wise, or quarter wise, month wise, or product wise, customer wise, and location specific. These are the different default dimensions and default factors we'll be having in this OBIE, and the customer is able to do the better understanding. And as part of this first thing, the customer has to analyze this business. So where he's getting this data, and what is this doing the business, and how is going to get the data. But I will give you some overview on this. So for example, if the customer is having any pharmaceutical company, so there he can able to manufacture some products, and these products can able to deliver to some country dealers, and from there to location dealers. From there to they will be moving on to the shops, medical shops, or pharmacy shops. So there the customers will go and buy some products like some injections or tablets. They will buy them from the customer store. In the storekeeper will enter will give the invoice or bills to the customers who are buy the some injections or tablets from the pharmacy shop. So at the time he is generating the invoice, he will enter the customer name. The bill will have these particulars like bill ID and bill to and bill date, customer name and location, and the product name what he buy, and quantity how many he buy, and the price of this particular product. So these are the particulars we can see in this bill. So using this information, this when he generates this bill information will go and sit in the particular shop storage system. That can be an Excel file, or that can be a Oracle database, or that can be MySQL. That can be any storage mechanism they are following. So this particular location they are using this type of storage mechanism. Just assume that Excel they are maintaining in the one of the store. But the same way, if we have the if we are the customer is delivering these products and selling their products into different locations and different countries. Just assume on somewhere on the UK they are maintaining MySQL database, or in USA they are maintaining Oracle database, and India they are maintaining just the Teradata. So different types of storage system they are using in different locations to keep this customer details and the sales details. Yes, uh, and you can hear me, right?
Yeah.
Okay. This way they are able to keep this storing the data into different locations in different data storage systems. So at the end of the day, what is the requirement for the customer? He wanted to analyze his business and global, on the world wise. How are the business is going on quarterly basis or weekly basis, on product basis or customer basis, or locations basis. In which season he is getting the huge amount of profit, in which season there is getting some losses. He has to analyze his business in different ways. So for that he will not go to each location, and he will not go to the reporting or writing some sequels, or building some reports on the different source systems. So what he will do, he wanted to extract this data, and he wanted to keep it in one centralized location. The centralized location can be called as a data warehouse. Yeah, the centralized location can be called a data warehouse. Data warehouse is nothing but a database, and it is having the data extracted from the multiple different sources and keeping it into one centralized location. How they are able to keep the data? They can able to store it into the data warehouse in the table format, in tables and rows. So these tables, how they are able to design? So we have multiple data in multiple databases, different data in different databases and different locations. How, how you are able to connect to them, and how you are able to extract it, and how you are able to load it into one of the data warehouse. And in the data warehouse, how you are storing it? In tables you are storing. Which table you are storing? How you are able to design this table? This is the whole process can be called as data warehousing or data modeling. So the data modeling can take care of here. So before data modeling, the data modeling team will able to identify the source system, and they will analyze the data and storing in the data source system. And they also consider the main factor as the requirements of the customer. So any project is going to start, they will have they will gather the requirements first. So in the requirements gathering, they will design a requirements document. So in the requirement document, what is the requirement of the customer? They will consider this factor, and they will able to analyze the source system's data, and then they will be able to take a decision to design a table name. So the table that can be a dimension or fact tables. In the warehousing, we have the different types of tables: fact tables, dimension tables, factless fact tables, and junk tables. There are different type of tables. So just assume that they are building one of the dimension table. How they are able to build the table? How to do that relation? So in the data warehouse, the tables will be in the relational model. In the data model or the relational model, the tables are related with each other depending on the primary key and foreign key relationships. How they are able to populate these keys and tables and relations. That is where they will analyze, put a lot of effort in understanding the requirement of the customer and understanding the source system data. And then, for example, we have here some of the information. Let us say bill ID. Bill ID is, let's say, 123, and bill to customer, and bill date 2015 October 26. Let us assume that customer name is MXYZ and location is New York, and the product name is, let us say, paracetamol, and the quantity he buy is 10 products he buy, and for the cost of $100. Let us assume. So this is one of the primary information he has in this one of the sources. So depending on this information, how he can able to take a decision to build this particular data model or to build this particular table. So there where we have data warehousing or data modeling techniques, like identifying the entities in the existing source data. Entity is nothing but what? In the data warehousing terminology, entity is nothing but a real world object which is existing in the real world, that can be a entity. So for example, bill ID. So bill ID is nothing but, bill ID can be assigned to the bill. So bill is a real world object and it is existing in the real world. So it can be taken as an entity. So using this bill ID, they can able to build a table. It is bill. Just assume that this bill. So entities once identified, they can able to build attributes. They have to define some attributes to this entity. Attributes are nothing but, attributes is, what is attribute? Attributes can able to define some information about the entity. The attribute of a table or a entity can able to provide some additional information about this entity. So what entity it is and what type of information this entity is holding, that is attribute. So the attributes can be bill ID, the ID of the bill. Every bill has its own ID. And bill to bill, you billing to customer or you're billing to the vendor, you can able to define the type of the bill to. And billed by, to whom you bill, bill location, in which location they bill, and bill code, barcode of bill, or you can just give some additional information here. So this is one entity. So you can take it as, in the data warehousing terminologies, if any entity is describing about itself, that entity can be called as a dimension table. A dimension. So if you define a dimension, the dimension has rules and regulations. One is, it should have a primary key column defined. and the rest of the columns has to describe about the table or describe about the entity. So you have the primary key column defined here. What is primary key column? Bill ID. As you know that every bill has its own ID. There is no case you have the same ID assigned to multiple bills. So you can take that bill ID as a primary key column. If you insert a record into this table, that means you are inserting a bill details. So every bill has its own ID. There is no bill without ID. So that means it is following uniqueness and not null feature. That means this is primary key column, and rest of the columns are providing some additional information about this entity, so that we can be able to identify this table as a dimension table. So in the data warehouse and terminology, tables can be having a naming conventions like this. If it is a warehouse table, W underscore and the table name and type of the table. D for dimension. The same way we can able to identify the other entities in the data. Single record of data, bill to and date, bill date. Date is nothing but a calendar information. So calendar is a and dates, months, weeks are existing world objects. So we can able to any data model you take, any type of data model you take, there should be date dimension will be there, and customer table will be there, location table will be there, product table is there, and sales table is there. Any if you take any of the any data model, time is mandatory dimension table. It is date or time. So you can just define the date or time. So this is timetable and time ID. Time ID can able to store the date information. Today's date is 31st October. Tomorrow is 1st November. So every day has its own date, and there is no day without date. So that means it is following the primary key properties. So we can be able to consider this as a primary key column in a time entity. In this time entity, we can also able to define the day name, a month name or month ID, week name, quarter name, year name, calendar year, fiscal year. So financial years and calendar years, you can able to populate n number of columns here, and all these columns are providing some information about the time only. So this is a dimension table, warehousing table, and this is type is dimension. This way we can able to populate a number of different type of. First, the data modeling team identify the entity and the data. So what type of entity is there? Is it customer is an entity? Customer can able to have customer ID. Every customer has its own ID, and customer has the name, address, phone number, email address, and pin code, mobile number. So we can able to enter multiple details about the address customer profile. And the same way, product has also an entity, product ID, product name, product description, product subcategory, product category, and we can able to product pack date, manufacturer date, and product expiry date, and the content, what are the contents you have used in this product. So everything you can able to add into this entity and attribute. So the same way, the quantity and price. How we can able to define this quantity and prices? These two are calculated items. These are not entities. So how what they do is simply they will add them into the fact table, because if you design some dimension tables depending on entity and attributes relationships, so fact tables can be designed in a way that you can able to do the join between or among the fact and dimensions. So how do the join? You can able to populate the foreign keys in this fact table. Just assume that our fact table name is sales fact, and our warehouse table is W underscore sales fact. So for this fact table, you are going to populate the foreign keys. What are the foreign keys we have? The primary keys of the dimension table can be populated as foreign keys here. Bill ID and time ID, customer ID, product ID, location ID. So this way we can able to populate multiple foreign keys, and we can able to insert the quantity and price. As per the data warehousing terminology, if a table is having the foreign keys and the calculable columns or measurable columns, and using which we can able to apply some calculations, the type of table is a fact table. Fact table can have the foreign keys of the dimension tables as primary keys of the dimension table as foreign keys and measurable columns. This is a fact table, and you can able to do the join using this fact and dimensions using the primary key and foreign key relationship. So this way we can able to design the data model, and we can able to load the data from the different source systems into the warehouse system. So we have the data warehouse and we have the data model and the tables created in the data warehouse, and these are tables are related. Now our requirement is to load the data from the multiple source systems. So there is an existence of ETL. So there is existence of ETL in our market. The ETL is nothing but extracting and transformations and load. Extracting. What is extract? There are multiple tools are available in market like Informatica, ODIEE, Agnesio, Data Stage, etc. There are different types of tools. Using these tools can able to connect to multiple source systems, because these tools can have a inbuilt drivers installed to connect to the different source systems, and they will connect to the different source systems, extract the data from the source systems. They will apply some transformation rules. Why do they apply transformation rules? Is to manipulate the data. So for example, at the time of transforming the data to the warehouse system, the data should be in qualified format, understandable format. Clumsy data, or if any data is having no meaning data, we should not move it to the warehouse. So the customer has to analyze the data on the warehouse only. So we need to show them a valid data which is understandable format. For that we need to do some transformations. So the storekeepers at the time of entering the data into the system, they may be doing some mistakes. So we need to identify where exactly the data is mismatching, and we need to apply some transformation rules, and then we can able to load it into the warehouse. So this ETL tool can able to extract, connect to the source system, and apply the transformation rules and load it into the warehouse. So now we have a data warehouse, and their tables are designed and they are related, and we have the data loaded into the warehouse system using the ETL tool. So that is where the customer is going to analyze the business again into the data warehouse. So here he has to run the reports. His requirement is he has to analyze the business. For that he will write some big queries, and he will just try to hit the database, and it's going to fetch the results, and the data can be exported into the Excel sheet, and then he has to again do the reporting on the Excel sheet. So he will write some queries to the warehouse, and data will be populated, and he can export the data into the Excel sheets, and then he can able to do the reporting again. So this is also manual intervention is there. To avoid that, he wanted to go with the automated process, to which can automated process. There should be some tools which can able to connect to the warehouse system, and depending on the selection of the columns, they have to populate the reports, and you can able to download them, and you can able to deliver them on a timely basis, and we can and they can able to display in interactive mode. Interactive mode is nothing but you can able to defining some action links, and viewing the same report into multiple views representation. So for that, what is the requirement here is the customer wanted to go with the reporting tools. So there are n number of reporting tools are available in market like OBIEE, Tableau, and Cognos, etc. There are multiple reports, multiple tools are available in the market. So currently the best tool in the market is OBIEE and Tableau. Both are in the competitive. So this OBIEE has the features, and this OBIEE is integrated with the WebLogic server to provide some high availability to the application. High availability and high security, and configuring the external LDAP servers. There are different types of additional features we have in OBIEE latest version, that is 11G, and the latest version released is 12C, and it is not yet approved in the market and qualified in the market. This is recently released, and our training will be on the OBIEE 11G now. So here I will give you uh, the today we are going to discuss on the creating the repository in 3 different layers. So OBIEE OBIEE is Oracle Business Intelligence Enterprise Edition Oracle product. The latest version is 12c, 12.2.1.0. So uh, this is not yet qualified in the market, and this has additional features. And so our version is, the training will be on this version 11.1.1.7.0. So any version, only they will be adding some additional features. There will be nothing changing as part of the functionality of creating the repository. Everything will be same. Some additional features may be added, and some look and feel may be changed. So our training is on the OBIEE. So before going to the OBIEE, I would like to give you some architecture of OBIEE. Okay, here is the architecture of OBIEE, and let me. Okay, okay. Here is the OBIEE architecture. So in this OBIEE architecture, in 10G version of OBIEE, we can actually have these components only: the BA server component, presentation, scheduler, cluster controller only. Whereas in the 11G, these all components are integrated into the WebLogic server. In place of Java host, in 10G we have the OC4J server. Whereas in the 11G, all these are integrated into the WebLogic server. They just integrated into the WebLogic server, and there is a controlling mechanism we have here. This is called OPMN. This OPMN can controls OPMN can controls the components, system components. So OBIEE in this WebLogic server, the OBIEE is all the area of this one only. This part is OBIEE, and this part is WebLogic domain, and this part is supporting schema. Three parts we have here. Supporting schemas. These supporting schemas are repository creation utilities, where these can able to create two schemas in your database. One is they want to BA platform schema and MDS schema, metadata management system. And here BA platform schema can able to store the domain information and log files information, and where the logs are located, usage tracking details, and session informations, and how many sessions are logging in into this. And there are different types of jobs information can able to store into this BA platform schema. Actually, these schemas can provide some supporting to the OBIEE application, OBIEE platform to run the different functionalities. Okay, here this WebLogic domain is having the two different types of areas. One is admin server, and other one is managed server. So what is admin server and managed server is? Admin server is nothing but a WebLogic server, and managed server is nothing but a manager server is an additional server we can able to get when you do the enterprise type of installation. So this manager server can able to provide some additional features to run the OBIEE application in a faster manner. So for example, if the thousands users are there in your application, and all are at a time trying to access the OBIEE application, manager server can able to manage the incoming flow of the request. The incoming flow of request is controls, and it will just switch among the multiple components. Okay, this admin server is WebLogic server. This WebLogic server is having the two different applications controlling. One is administration console and another one is enterprise manager. The administration console and enterprise manager. Using this administration console, you are able to perform the creating the users. As a developer, you are able to perform some creating users, the basic area, and assigning the users to default groups. And you can able to monitor the deployed applications, WebLogic deployed applications, and log messages of the admin server and WebLogic server and manager server. And you can able to see and you can able to control the status of the services, status of the admin server and manager server, health status of the admin server and manager server. And coming to the enterprise manager, using this enterprise manager, you are able to perform deployment of the repository and defining the catalog path, verifying the OPMN health status, OPMN services health status. These are all OPMN services. OPMN is Oracle Process Manager, and it can able to control the system components. What are the system components we have is BA server component, presentation services component, scheduler server component, cluster controller, and Java host. So these 5 components, health status, and you can able to start all of it at a time and controlled by the OPMN only. And you can also able to see the, you can able to perform the configuration management, performance management, and cache enablement, and you can see the log messages of all these 5 components in this enterprise manager. And this is many things we can do using this enterprise manager, like repository deployment as well, catalog settings, and defining the mail configurations. If you want to enable agents, how to do the mail configuration, everything can be taken care in the enterprise manager only. And if you coming to the security part, you can able to create the application roles. This is new in the 11G version. Application roles can be created in the enterprise manager, and the application roles will have a policies defined, security policies defined. That is comes into the administration part, and here we come to the manager server. The manager server is having some additional features like action services, BA office, BA publisher, web services. So this all this can be controlling by the manager server. You have, for example, BA office or BA plugin. BA office is nothing but you can able to plug in Microsoft MS Office, like Excel, MS Excel. You can able to add a plugin to the OBIEE, and this connect to the OBIEE catalog, and we can able to browse the reports of OBIEE catalog in the Excel sheet. So this type of plugin services. And publisher, BA publisher is also an additional tool integrated to OBIEE, and that is deployed as a web application or enterprise application into this manager server, and they can able to the actions performed in the BA publisher can be controlled by this manager server. And web services, you can also able to external web services designed in the or developed in the J2EE code or Java code. You can just able to deploy that web services .wsdl files into this WebLogic server. And security is also able to managing by this manager server. And there is a node manager. It can able to manage the nodes of the multiple nodes in the WebLogic server. So if you can configure the clustered environment, that can be a horizontal or vertical environment, vertical clustered environment. So when you perform the horizontal clustered environment, this node manager can able to help you to switch the incoming request between the multiple nodes. For example, admin server. So it will have the node 1 as BA underscore server 1. That is one of the manager server as a node 1, and BA underscore server 2, that is a node 2. Like that, we can able to configure up to 16 nodes maximum. So among the 16 nodes, if you configure, that is to provide the high availability of the application in a horizontal clustered environment. If the incoming requests are coming, so the node manager can able to help you to switch them on the different manager servers. So this is coming to the under administration part. Coming to our system components, we have BA server component, BA presentation services component, and scheduler component, and cluster control. BA server can able to manage the repository and the sessions information and security, and taken care by the BA server. So the BA server is the main component in our OBIEE, which can able to create the physical SQLs, which can able to convert the logical SQL into physical SQL. So what is logical SQL and physical SQL is, the physical SQL can able to execute on the database, whereas the logical SQL is populated by the presentation services. Depending on the column selections you selected in the report, For these columns, the logical SQL statement can be prepared by the uh, logical SQL statement can be created by this presentation services, and the presentation services passes this logical SQL to the BA server, and the BA server will convert the logical SQL to physical SQL statement as per the column mapping you define in the repository. In the different layers we have, right, physical layer, logical layer, and presentation layer. So depending on this logic layers development, logical SQL will be converted into the physical SQL statement, and that can be executed on the data warehouse or database is through the connection pool details. And moreover, the BA server can able to control the session information, who is logging into the application, and its session logged on time, logout time, and the session IDs. And the presentation services also is used to create some reports, dashboards, filters, agents, and in the different types of views, table views, pivot table views, graphs, bar charts. There are different types of view representations out there. And the scheduler server is useful for us to uh, control the to deliver reports to the end user's email address on particular time of on a particular time frame. You can have a frequency defined. The frequency is nothing but schedule time. You can able to schedule a report or a dashboard page to the end user's email address on particular time of interval. By the time scheduler server raise a trigger or events raise a trigger to the PA server to run the report, and the report executed report result set will be delivered to the end user's email address. The cluster controller is used to, when you perform the vertical clustering, in that case, yes, this can able to controls the incoming request and switch the incoming request among the multiple components. So when the vertical clustering, you can able to see the multiple BA services, multiple presentation servers, multiple scheduler servers, multiple Java host servers. You can see in the vertical clustering. More than one BA server, more than one presentation server, you can see that. And the OPMN is used to control these components. So that's why we have a OPMN controller, OPMN CTL, CTL in controlling. OPMN controller hyphen stop all or start all. You can able to use the command line command to run the to stop or restart the OPMN services. This is the high level architecture of OBIEE, and we can able to move on to the building the repositories. How to create a repository. Before that, let me open up my local enterprise manager. Okay. Okay, there is when you install the OBIEE, in the start menu, all programs, we can see the Oracle Business Intelligence folder created. So this folder will have a additional files like starting the BA services, stopping the BA services if you want to start or stop the services, and BA administration. This administration will help you to create the repository. So what is repository? Which is having three different layers. So the repository is nothing but a file which is having the metadata, and this file can be able to create or modify or edit, or you can able to customize that file using this administration tool. This administration tool can help us to create or modify the .rpd file. The .rpd file is nothing but a repository directory file. This can be deployed to the BA server. Okay, using this administration tool, we are able to modify the or create the repository file. Okay, let us create a repository file here. Log into the enterprise manager. Once we done the repository development, we can able to deploy to the enterprise manager as well. login is in process. Okay, this is the administration tool which can help us to create a repository file, that is .rpd, or to delete or modify the repository file. Okay, to create a repository file, there is an option to create a new file. Here is the new option, or can you select the file menu, new repository. Select new repository. Okay, this is the wizard where we are able to going to create new repository wizard. Under the step 1 repository information you are going to provide. Okay, whenever you are working with the multi-dimensional sources like SBS cubes, then you need to give the XML files as a source system, and you need to pass that XML information into this by browsing the XML files here. So currently we are working with the binary type, that is data warehouse. So give the repository name as some sales repository, and the path of the location of the repository I'm going to give that on the desktop. And import metadata. Import metadata is nothing but what you are going to, metadata is nothing but the data about the data. So you have a table name or column names, these are all metadata. The data will not come under the metadata. So the metadata can give you some idea or some information about the data. That is metadata, that is column name. For example, country name is a column name. So in the country name, what type of data you can save? India, USA, in UK, like that, China. You can able to save this type of values. So these values, by these values, what you know, these are country names. So this data can able to describe something about the metadata. Metadata can able to provide some information about the data which you have. Okay, the metadata comes under the table names, synonyms, primary keys, foreign keys, and and views. All these comes under the metadata. The repository password I'm giving is admin123. Admin123. Click on next. I would like to input metadata right away. Click next. There is already exists. Yes, do you want to replace it? Yes. Okay, this is the second step, selecting the data source. So with this step will help us to select the driver type to connect to the database and providing the database connection details. So in the OBIEE 10G version, we are using the ODBC driver 3.5 as the driver to connect to the database. Whereas in the 11G, we have a new driver, that is OCI, Oracle Connection Interface, and data source name is ORCL. In my case, in the data source name is nothing but the connection string name. You can get that in the TNS names.ora file. And here I have a sales history schema which is going to give us a best schema to give us a practical purpose of OBIEE. We can be able to have all the required tables in this sales history schema, so that I'm using this SHS or schema to build some reports and to do some development in the repository. This schema can able to have the different tables which can able to populate the different type of star schemas, snowflake schemas. Click next and it is going to not responding.
The data source name is whatever name we are providing at the time of Oracle installation.
Actually, yeah, database creation, you are giving the database name, that one. So once you create the
Okay.
database name, there will be a connection string there. In your TNS names.ora
Yes.
file, you can see that connection string.
Yes, correct. Okay.
Yeah, ORCL, the connection string you need to pass.
Oh, okay.
Let me kill this process. Okay, it was just connected to the database. Meanwhile, I'm going to connect to the console as well. Okay, it is just connected to the database. So here the types of the metadata here, select the metadata types you want to import. Okay, select the metadata types as tables, keys and foreign keys, or system tables, aliases, synonyms and views. These are all comes under the metadata types for this database. Okay, select the tables and keys and foreign keys. If you import the tables and its foreign keys and primary keys, then what will happen is the tool itself identify what is the key column and what is the primary key column and what is the foreign key column, and then it will do the join automatically. It just do the join automatically, but because it's know that this is the key column and this is the primary key column and this is the foreign key column, and it will do the joins automatically. So to do the joins manually, I would like to import them only tables. Click next. Okay, so once it is when you click on the next by selecting the tables, it is populating all the schemas available in your database overseer. So that is our schema is sales history sh. Just expand it, and here we have some set of tables which are useful for our data modeling. So I'm going to select those tables: channels, countries, customers, products, sales, times. In the real time also, you just select these tables which are required for your development, and you can just select this import selected tables into this repository. Okay, it is asking for the connection pool details. We will explain. I will explain what is connection pool. I think it is importing all the tables. By mistake I selected the schema name. I think it's importing all the tables. Let me cross check it. Okay, let me open it and create a new one. Take a new repository, name it as sample sales underscore history. In the repository name, we should not use any spaces. We should give the underscore instead of space. Location, I'm going to save it under the desktop, and the repository password. Click next. The data course name was here. Deselecting the keys to import only tables. So here our SH, and here I'm going to select the sales as factory world, channels, countries, customers, products, times, and these are useful for us to do the sample development, and this is the connection pool details. So importing only these tables. Okay. Our tables gets imported, and you can see this, and just click on finish. So this is physical layer importing the tables into the repository. So using the by the time of creating the repository, you can able to import it. And other area is go to file menu, import metadata, or right click on the physical connection pool and import metadata. And these are also other areas after importing metadata. If you want to import them again, or if you want to import any new tables or new columns, you can just use these options. And once you import into the repository, these all you can see the OSCL, connection pool, SH. These are all created here. What all of these actually is? This one is physical database. In the physical layer, this can be called as database, and you can able to rename it. Just click, select it, and click on F2 or rename. Right click on that and rename it. As per your requirement, you can just rename it. Let me rename it as sales history schema. And connection pool, by default name is connection pool, and you can able to see the in this connection pool you are able to see the data source name which you given, username and password, the data source name or current connection interface. And if you want to rename the connection pool, you can able to rename it. And you have see the physical tables here. And in the OBIEE, we have a concept called all these are the physical tables, and we can see the physical columns as well. Excuse me. And if you want to, for example, in your database house, you have a table which is having, let us say, 100 columns, and you don't need all these 100 columns into your reporting. You just need only 5 to 10 columns in your reporting. So for that, what you can do, you can able to create a view. You can just import the whole table, and or else you can able to create a small table. Just right click on the physical database, new object, physical schema. Right click on the schema, new physical table. Okay, name the new physical table as let us say cust. Let us assume cust. It is cust. Cust underscore do. Let us assume the customer duplicate table I'm going to create. Assume that customer table is having millions of 100 records. Among that, I don't want to import all those tables. This is my general table, properties, name of the table, and table type. This is a physical table, but it is not imported from the data warehouse. You have a table in the data warehouse with the same name or other name. From the table, you want to populate some of the columns only. For that, what you can do, if it is imported from the data warehouse, you can see the table type as physical table. Or if you want to write a stored procedure as well, you can able to populate a table in the physical layer by writing some stored procedures or select statements. So these select statements can give you just like views. However, you create a views in the database, the same way you can able to create a views in the physical layer as well. Customer ID. Okay, the naming conventions. So I'm going to give the select statement here, creating a view here actually. Cust underscore ID, cust underscore name, last name, cust underscore gender, cust underscore email. I only need these columns only from the customers table. I just written the SQL and click on apply. You can see the table created here, and this table don't have any columns. You have to create the columns manually. Otherwise, you can just import the whole table, just like customers. You can import the whole table, and you can put the SQL statement here, the same SQL statement, and you will get the view icon here, and you can all the tables, all the columns are already listed here. And if you want to create the columns in the select class of the SQL statement, the select class of the SQL statement, what are the columns you have, those columns you can able to create manually. To create any new column, right click on this new object, physical column, name of the column, customer ID. What is the data type of it? You can able to select the numeric type or integer type. Any type you can able to select here. Numeric. Assume that. And the other one is new object, new physical column. You can create a column here. Customer last name. And data type of this one is varchar. And the same way you can able to select other create column alias new table, new physical column. So this means we are able to create a views in the physical layer by using this select class option, that is table type option. Customer email varchar, customer gender is also, let us define varchar for now, and we have created the columns as well. And if you want to see this SQL is executing properly and our columns are executing properly, right click on that view data. See, you are able to see the customer email address, customer gender name, customer ID, and customer last name as well. So this is how we can able to create the views in OBIE physical layer by decreasing the number of columns, and this view can be called as opaque view. OPAQUV, opaque view. So opaque views can be created in the physical layer. So this is one of the concept by customizing the existing table, and you can also able to create the views from multiple tables by applying the join conditions. But at the end of the day, what are the columns you have in the select clause of the SQL statement? Those should be listed under the table name, like this. However, we created the column name, the same way those columns should be listed here. Then only our SQL statement going to execute properly. This is how we can create the opaque views. And the next one is, so once we input the metadata, you need to identify what is the dimension and what is the fact table. And once you identify the dimension and fact table, the next requirement is create a alias table on top of that. Okay, next one is creating alias tables. So first we need to identify dimension table. You can see this channel ID is having the look like primary key column. Use the data. Channel ID, unique data. There is not null. And you can see that every column is describing something about the channel only. Direct channels, indirect channels, others channels. So that means it is a dimension table with the primary key column as channel ID. The rest of the columns are describing something about the channels. So this is a primary dimension table. So once you know this is a dimension table, the next step is create an alias table. Just right click on the table, new object, alias. So why do we create the alias? If you know it is a dimension table, just name it as dim channels like this. Why do we create the aliases is to avoid the circular joins. This is very small data model. Just assume that if you have a bunch of tables in your data model, if you have a bunch of tables in that, by doing the different requirements, by processing the different requirements, there might be a situation you may be fall into the circular join. What is circular join? The circular join is nothing but then your join condition, depending on your data modeling, the join conditions which you performing may be fall into the circular join. Assume that you have three tables here. Just link this table to the table 1 to table 2, table 2 to table 3, and table 3 may be joined to the table 1. In this case of situations, you may be fall into the circular join. So to avoid this situation, what you can do, you can simply, what you can do is simply remove this join and create a alias table for the A1 D1. This is the alias table for D1. This is alias table, and you can just able to do the join from D3 to D8 or D1A to D3. So you are breaking the circular. That means if you are in the circular join, the data will be duplicate and it is invalid. So to avoid the circular joins, what you can do, simply you can able to populate the alias table. And the other situation is um, already the join we established between this D1 and D2. Already join condition established between the D1 and D2, and if you want to do the join again from D1 to D2 on different situation. For example, you have a timetable. In the timetable, you have the data stored into a day-to-day basis. The fact table is also data is storing in a day-to-day basis. And if you want to compare the results of analysis from current year to the previous year or current month to the previous month, so you have only two tables, time dimension and fact table. How you are able to populate these two values in a single report? Current year sales and previous year sales, or current month sales or previous year sales or previous month sales. For thus, Actually, what we can do to populate in the time dimension table is current year, a year ago, or current today. If you have, for example, today if you have the date as 2015 10/31. So in the year ago time ID, this is, let us assume this is time ID column, and the year ago time ID, how the data will be stored, 2014 10/31. So this, for this date, this is the previous year date. This way they can able to populate in the same table. In the D1 time table, they are able to populate the two columns, one for to store the current dates and one for to store the corresponding current date, previous year date. So what they can do, we have two key columns. One is primary key column as time ID, another supporting primary key column as year ago time ID, and we have a one fact table. And this one is year ago time ID. We have two different columns in this and using this table we are able to perform the one join to the fact table. There is one join between time ID and time ID dot timetable dot time ID is equals to fact table dot foreign key column time ID, so which is going to get the current year sales, and other one is year ago time ID dot year ago time ID is equals to fact tables or time ID. The condition is looks like that. If your times table is there, times dot time underscore id is equals to fact table dot time id. This is one condition, and other condition is what, this join condition will get us the current days going on days data. What are the days going on, those days data will be getting, and other join condition we can able to populate as uh, time dot year ago time id equals to fact dot time underscore id. This is going to get the previous year sales or previous month sales, whatever the id column you have here, this corresponding year ago sales will be populated here. So if you want to do this type of joins between two tables, you can able to perform only one join to one table. If you want to perform multiple joins, what you can do is you can able to create the another dimension table as alias table, that is d1 alias. So d2 one join, d1 to d2, d1 to fact one join, d1 alias to fact another join. So you can able to, that means what you are doing, you have only one table and using it for multiple purposes. Purpose one to get the current year sales, purpose two to get the previous year sales. That means you are using a single object for multiple purposes. So that's why we create the alias tables. One is to avoid the circular joins, very important interview question. To avoid the circular joins, we create the alias tables, and to reuse the single object or single table for multiple purposes. For example, this one, that is the alias tables, why we create the alias tables question. And the other one is countries table. Here we have the country as a primary key column, the rest of the columns are identifying, providing some information about the countries. So this is also dimension, new object alias, if it is dimension, dim countries. Customers is also a dimension table. And products product is also a dimension table. As you can check that because the product is having primary key column, rest of the columns are describing some information about the product entity. So if you can see the sales table, it has amount sold and quantity sold as a measurable columns. Using these two columns, you can able to apply some calculations, and you can see channel ID. Channel ID is a primary key column in the channel dimension, whereas this is a foreign key column in the sales table. Customer ID is also a primary key column in the customer dimension. Here it is a foreign key. Product ID, primary key column in the product table. Promotion ID, promotion is a primary key column in the promotion dimension. We did not import it. And time ID is a primary key column in the times table. So it is having foreign keys and measurable columns. So we can able to identify this is a fact table. In the real time, we should not have the tables in this type of very easy manner because the tables may have different key columns and different dimension columns or factable columns. So you need to identify which is going to, when you do this joint with this table, what will happen in the back end. So by analyzing the data and by doing the logical thinking, you can able to identify which is the table and which has to do the join. If you have a design team, they will give you the document which table to be joined to which table. Okay, in this times table, this is also dimension table, new object alias dim times. So we have created the alias tables. So next step is do the joins among the created alias tables. No need to do the joins to the original tables. Simply create the alias tables and do the joins among them. Select all the alias tables, right click on them, physical diagram, selected objects only, new object, new join. So this join options will be enabled here and you open a diagram. So select a new join here and select the fact table. So in the 10G, from dimension to fact we will be linking, but in the 11G, link between fact to dimension. So product ID is the primary key column in the product table, whereas here product ID is the foreign key column. So products.product ID is equals to sales.product ID. Click OK. The same way to times. Time ID equals to time ID. Sales to customers. Customer ID is equals to customer ID. Channel ID is equals to channel ID. And you can see this country ID will be available in the product dimension here. So in the customer dimension we can have the country ID. So here we have the country ID as a foreign key column. This is the primary key column here and this is the foreign key column. So we did not import any key columns. By depending on the joins we did it automatically identify what is the key column here. See, automatically select it as a key column depending on the join you do. So this is one of the data model we have created. Let me open it again. See here, this country is not having any join for now. One is fact table, and fact table is connected to the multiple dimension tables. So this type of data model can be called as star schema. So a single fact table can be surrounded by multiple dimensions. That is a star schema, and these dimensions are not having any join with the other dimensions in other level. So that we call it as a star schema. And if you do the join from customers to countries, country ID is equals to country ID, then this type of data model can be snowflake schema. Usually in the real time, if you do the star schema, the performance will be better, and if you do the snowflake, little slow in the performance point of view. This is snowflake schema because this customer dimension is having a join with the other dimension and the different level. So this is snowflake scheme. So we have created the physical joints, and we have the data model is completed in the physical layer, and we have first we have inputted the metadata, identify the dimensions and facts, and created the alias tables, and we did the join among them. This is the development we do in the physical layer. So once it is completed, move on to the logical layer. Create a new business model folder. That is again a sales history. Click OK. Select all the alias tables and drag and drop it onto the logical layer. Simply dragging and dropping. So once you drag and drop it, all the tables at a time, it will identify, it will carry the joins as well. It will carry the physical joins into the logical layer. This is logical layer or business model layer or mapping layer. This is business model and mapping layer or logical layer or BMM layer. You can call it in any way. So it is carrying the physical joins to the logical layer, and it is identifying what is the fact table depending on the joins. So and it will give the hash icon on the table icon for this fact table. So when you drag and drop logical tables into the logical layer, you can see the joins created automatically. Joins also populated in this logical layer. Business model diagram, whole diagram. See, these are the logical joins. You will not have the conditions for the logical joins. You will not have any conditions for the logical joins, and you are able to define the type of the join in the logical layer, but not in the physical layer. The inner joins or outer joins you can able to define in the logical layer only. You should not define it in the physical layer. And the coordinate you can see many to one. Many is the fact table, one is the dimension table. Because the fact tables will have the duplicate records, whereas the dimensions will not have the duplicate records. And so once you drag and drop into the logical layer, so the next step is if you want, there are different things we can able to let me drag and drop it into the presentation layer as well, the whole business model folder. So when we drag and drop into the presentation layer, that can be a subject area. Subject area can have presentation tables and presentation columns. These are presentation layer objects. So presentation subject area, presentation table, and presentation columns. And this business model mapping layer is having the logical table, logical business model folder, logical columns. So additionally, we can do lots of development in the logical layer only. Creating the hierarchies, creating the new logical column, defining the aggregation rules. Everything can be performed in the logical layer only. Okay. Before going to that, I would like to save the repository and check the consistency. Consistency is valid, and there is no errors or warnings or any best practice violations left to report. So there is no errors or warnings in our development up to now. This is very primary repository development. When you do the repository development, this is very basic repository development up to now. And now next what I'm going to do is, there is a concept called log levels. So there are different types of log levels we can able to define to the users. So the log level can be starting from the 0 to 7. So when you define the log level as 0, what is log level is, so when you run a report, when any user log into the application and try to run execute any report or dashboard, that particular report related SQL can be stored into the log, can be written some log. So depending on the log level you define, the log will be written. So if the log level is 0, log will not be created. If the log level is 1, some part of the log will be created, that is logical SQL will be shown you in the log. So when you define it as 2, along with logical SQL, you can see the physical SQL as well in the logs. So that is what we were going to do here. After deploying the repository, we can see that log levels, creating new logical columns, defining the properties and permissions for the logical column, and creating complex formulas, and how to work with the creating dimension hierarchies and time series functions, we can see that. Okay, let me save this repository, and we have saved it and close it to deploy the repository to the server. Okay, to deploy the repository to the server, need to log into the enterprise manager and go to the business intelligence core application. Once you log in, you can just click on the core application. It will lead you to the uh, login page. Okay, here we are going to deploy the repository. So under the business intelligence core application, here we can see the change center. Now the configuration is in disabled mode. If you want to enable the configuration settings are nothing but once you deploy a repository to this enterprise manager, that repository can be copied to the BA server component, and then the configuration file of the BA server component can be updated. That is nps config.ini is the BA server configuration file, and that is going to update with the latest repository information. Further, click on the lock and edit configuration here. Now the configuration is locked by WebLogic user and it is in editable mode. And here under the deployment tab, we have repository subtab. Under the repository subtab, we are going to deploy the repository. Choose repository file. Upload BA repository. Choose repository file. Desktop. We saved it to the desktop. And here we have sales history. It is just we created it 10/31st. Open it. Sales history. Sales history just uploaded here, and the password of the repository. Okay. We can just give the password of the repository and confirm the password. And here is the catalog location. In which catalog you want to save this repository related development. The catalog is nothing but once you deploy the repository, you do the reporting, right? The report building reports in different views. That where do you want to save it? That path you can able to define it here. I'm just using this sales analytics folder to store the catalog, and click on apply here. Upload a repository, click on apply. Okay. Applied successfully, and the default RPD is sales underscore history BS007. That means for every deployment, it will give an instance number to the repository. It will copy it to the repository folder and it will deploy it as a separate name, sales history underscore BI007.rpd. For every deployment, it will add a new instance number to that, and then activate changes. The changes can be activated. Once the changes are activated, we need to do the restart of OPM and services. There is system components to be restarted to take these changes affected on the BA server end. Okay, changes are completed successfully, and a restart to apply the recent changes. So here click on the restart option. Either we can do restart from here, otherwise we can able to do it from the command line. So there is a command called opmnctl. It is opmn controller stop all. Okay, do you want to restart from here? No need to restart from here. I'm going to restart from the command line. We can do we can able to do the restart from anywhere. So in the command line it is fast comparing to the application based. opmnctl stop all. Still, this process takes some time depending on the operating system or depending on the hardware configuration settings you have in your machine. Okay, you can check the status of them. opmn status. These are not running, and now you can able to start the opmn services. This is going to take little amount of time. You can just if you want to take the break for 5 to 10 minutes, you can take that. Hi Vinod and Pani. Hello, you there? Okay. Hi Fanny.
Yeah, I'm here.
Hello Fanny.
Hello, Srini.
Yes, Vinod.
Yeah. So, how much more duration is left for this training?
Yeah, 1 more hour. It is
Oh,
right up to 9 o'clock. We can have this repository development can be completed. Tomorrow we can
okay,
focus on the report development.
okay. So, how many days training is this?
2 days, Saturday and Sunday.
2 days. Okay, okay,
3 hours on Saturday today and 3 hours tomorrow.
okay.
Hello, Funny.
Hello.
Yes, Funny. You are back, right?
Hello. Yeah. Yeah. Yeah.
Okay. Let us continue the rest of the part. So I have started the services and the services are up and running now. You can see the status using this command OPM and CTL space status, and all the services are up and alive. There's all the system components are alive. And now let us open the repository which we developed in the recently in the online mode. So previously there are two types of modes to open the repository. One is online and one is offline. So when you open the repository in the offline mode is nothing but you are opening a repository which is somewhere on the hard disk. And online mode is you are opening a repository which is currently reading by the server. The deployed repository which is currently server is reading, we are going to open it. Okay, open it in online mode. Now we have developed deployed one repository. Let us open it in the online repository password and the WebLogic password. And you can see this repository is opened in online mode from the driver and the server name, host name. This is our repository. We just deployed it. The sales history in the business model and presentation subjects area. So this is a repository online opened, and now I'm going to create the log levels. Log levels. Why do we create the log levels? Is to see the log information for every activity or for every report the user is running on. The user wanted to see the log information. If he get any error message, he will go and check it in the log message, and he can able to extract the SQL statement. And there is interview question on this. If you want to extract the physical SQL statement executing on any particular report, where you are able to get that physical SQL statement is in the logs, manage sessions logs. For that, go to the manage to enable the log levels, identity. In the identity management, it will show the applications groups, available application roles, and go to the action menu, set online user filter to get the users star. Okay. So action menu, set online user filter. It will give you the when you define star, when you click on OK, it will list out all the users available in your application. So WebLogic is one of the user. Okay, let me go to the WebLogic properties. Double click on the WebLogic user, or right click on the WebLogic and go to properties. And here we have the logging level option. The logging level for the WebLogic is 0. When the logging level is 0, let us see the when we define the log level as 0 for any report. Let me run a sample report. So this is analytics application which is used to create reports, dashboards, different types of catalog objects we can create here. And this is the application the customers can able to browse and to do the analysis on their business. let me go to the take a new analysis. So here we can able to just add the columns. Any column you can just add, country ID or country name. Just double click on them, gets added. The amount short results. So country wise amounts sales information you are looking into this report. And for this report, what is the log level created? When for this WebLogic user, log level is currently 0. So when we define the log level as 0 for any of the report executed by the WebLogic user, log level will be log cannot be written because the log level is defined as 0. For the log level 0, there is no log found. Message you can see. So report is executing right now, and you can see the administration tab to see the log levels. Navigate away from this page. So under this session information, session management, we have a manage sessions. Click on that. Here we can able to see the log levels. That means for this user, every login is a session. So for this session management, for this user is executing this different requests. This is one of the requests. For this request, log message is view log. Click on the view log. Administration, manage sessions, and click on view log. See, no log found message because he has defined the log level as 0. Now I will go to clear this request. Going back to new page, new analysis, and I'm going to define it as 1. Click OK. Check out. Of any change you do in the online mode, that object has to check it out first. Once you check out, and if you want to save the changes, you need to check in the changes first. No need to check the consistency all the time. Save the repository. So you have defined the log level as 1 now. For the same request, if you define it as 1 and you want to reload the server metadata, so if you do the changes in the online mode for the repository, and if you do some changes in the analytics application, the changes to be reloaded into the analytics application, of the repository changes to be reloaded in the analytics application, you need to click on this reload server metadata. This will reload the metadata from the repository into the presentation services. So once you reload the server metadata, you can refresh the same request again. Reload server metadata completed and refresh it, and also just refresh it, and you can see the log message created now. View log. So when you define the log level as 0, no log found. When you define the log level as 1, this is the sequence. When you define the log level as 1, you can see the log messages created here. In this log message, what it is showing is logical SQL request. Logical request. This is select the column names from subject area. So this is whenever you see the from class has subject area name, that is a logical SQL statement. So when you define the log level as 1, you are able to see the logical SQL statement. Now I am going to define the log level as 2. So when you define the log level as 2, you are able to see the logical SQL statement. Additionally, you can see the physical SQL statement. When you define 3, you are able to see the execution plan of the logical SQL statement as well. When you define it as 4, you are able to see the execution plan of the SQL physical SQL statement. And when you define it 5, you are able to see the execution plan intermediate levels. So there will be entry questions about how to define the log levels, and when you define log level as 0, what will happen? When you define it as 1, what will happen? There will be entry questions.
In general, what is the value for the log level in real time?
2.
2. Okay.
To see the physical SQL statement for developers, we can enable uh, the log level as 2.
Okay.
So when you define 0, no log form. 1, logical request. 2, log level 1 plus, additionally we can see the physical SQL statement. When you define log level as 3, additionally to the log level 2, what it is logging, additionally it is logging the execution plan of the logical SQL statement. Log level as 4, additionally it is logging the physical SQL statement execution plan. 5, intermediate levels, and 6, it is also displaying the row counts and the db hits, how long the query executing, additional information it provides. And the venue 7 is for future reserved purpose. There is no information for the log level 7. It is reserved for future purpose. Whose future? Define it as 2. Click OK. What I did is I defined the log level as 2 here. It's being too slow today. Okay, let me open it again in that online mode. Go to manage, identity, WebLogic, right click, properties, just check out. Manage identity, check out. occurred while trying to check the objects from the server. Please verify the server setup. Okay. At the time when this repositories were forcefully we closed, right? So it was go to the hang state. So we may need to restart only BA server component. I will restart only the BA system. This command will restart only the particular component instead of all of them. Take a new analysis. This time we take the analysis on the product category. Reload server metadata. As we did the changes in the online mode, we need to reload the server metadata of the repository. Okay, server metadata gets reloaded, and you can add production description and product category results. For this specific request, we can see the log level created. Go to administration, away from this page, manage sessions. So here is the request. Product category and product description we have added. This is the view log. So here you can see the logical SQL statement and the physical SQL statement. Select distinct product category and product description from products table. So when you define the log level 2, we are able to get the logical SQL, physical SQL. When it's 3, logical SQL, physical SQL. Additionally, you can see here logical SQL execution plan. The same way, when you define 4, we can see the physical SQL execution plan. 5, in the intermediate row counts. So in the execution plan, what are the intermediate row counts we have for the execution plan? That is about log levels. And let's move on to the, so here when you do the analysis on this primary development repository, if you're trying to do the analysis on this by adding a I will take a small analysis here. Product category wise sales information, I would like to do the analysis here. So for that, product category sale information. So this is the data it is showing up here. For the electronics, this is showing this amount of sales. So we don't know what is we are not able to do this type of analysis as it is in the very detailed level. because the amount sold table column is having the data stored in a day-to-day transactions, day-to-day basis. You can see that in the by adding the time ID. Time ID is a primary key column of the time dimension. I'm adding that also into the analysis. You can see this particular day. Let me remove this product category. See, on the day January 1st 1998, in this particular day we have this many of records, this many of transactions are happened for this amount sold, this many of transactions are happened. So he is not able to do an analysis. If they wanted to see on a daily basis only, we have multiple transactions. He is not able to do the analysis on which transaction happened at what time. He is not able to do that. So what we can do is, this is very in detail, right? So we can able to summarize this, and we can able to sum up all these values, and we will display it as a single value for this transaction, for this day. For that, what we can do, we can able to apply a sum function for this amount sold. As I told you, this amount sold column and quantity sold are the calculable columns. We can able to apply the calculations using them. I am going to sum up the amount sold. So now it is measurable column. If it is a measurable column or aggregated column, you can see the, if it is aggregated column, you can see the icon is yellow color bar. Now the data is in understandable format. See, now in the particular day, these are the some of the whole transactions are happened. This is the whole value, single value for the day. On this day, this is the value. On the 4th January, 5th January, this is the amount sold. Now if you add the month column, you can able to make now the data is making some sense. So to define the aggregated columns in the repository or in the presentation services, you are simply adding a sum function to the existing column. Why we are adding this sum function? Instead of displaying the data in the detailed manner, you are able to summarize the data to particular level to particular level by adding a aggregation function. So this is nothing but defining the aggregation rule. So how to define the aggregation rule in the presentation services is edit formula and sum of column name. Whereas in the repository, if you want to define the aggregation rule, the logical layer, expand the table, this is the amount sold column, and double click on that, check out the properties, and in the aggregation tab, you are able to define the aggregation rule as sum, and you are able to define the aggregation rules as average, count distinct, maximum, minimum. These are the different types of aggregation rules you are able to define as per your requirements. So for now, I am defining it as sum function. Click on OK. That means the aggregation rule for the amount sold column is sum. So every time you use this amount sold column, depending on the dimension attribute you added, the data can be summed up. The same way you can also able to do that for the quantity sold. Define aggregation rule as sum here. Click OK. So now the concept is defining the aggregation rule to the logical column. Simply go to the logical column properties and aggregation tab, rule as sum. Why we do define the aggregation rules? Depending on the dimension attribute you added in the analysis, the data can be shown up in a summarized manner instead of displaying in a detailed manner. Now you can see the difference in the change in the results. You don't have any consistency issues. So if you do the changes to the existing logical column, no need to drag and drop it into the presentation layer. The changes will be automatically reflected here. If you create any new logical column, that should be drag and drop it into the presentation layer as. And now reload the server metadata to refresh the changes into the presentation layer. Let us reload the server metadata. remove this analysis, and now see the time ID, add the time ID and the amount sold results. Now no need to apply the sum in the presentation area. In this area no need to apply the sum function, automatically calculated in the BA server end. BA server is calculating. If you do any changes in the repository file, thus calculations can be performed by the BA server only. If you do any changes in the presentation side, the calculation can be performed by the presentation services component only. So now you are able to define the aggregation rule and you are able to see the data in a summarized manner. Now you can able to add any type of the column. So this is how we can able to define the aggregation rules in the repository. And now the next column, next option is creating new logical columns. Right click on the new object, new table, new object, and say new logical column. The logical column name is, let us say, total sales. And this logical column is new object, new column, and this one has, this one has to be define some source information. Every logical column, every logical column has its own source. In the under the column source tab, you can see the source information. This derives from, this section will show you the formula for this logical column. Sum of fact sales dot quantity sold. The fact sales is a logical table, sorry, the physical table, and the quantity sold is a physical column. For that column you are adding a sum function. So this is the formula for this logical column. The same way we can also able to define a formula for this newly created logical column under the column source tab. And the formula for a logical column can be defined in two ways. One is derived from physical mappings. Derive it from the physical column mappings. Edit, and here we have the physical column mapping. So this window can be called as logical table source, LTS. LTS. So for every logical table has its own sources. So this LTS is called sources folder. Under the sources folder you can see logical table sources. So to which physical table this logical table is having mapping information, that can be seen in the logical table source. This logical table source is having source information to the physical layer, and how it is mapping to the physical layer in the table level and column level. What are the columns are mapping with which columns, you can see under the logical table source properties. So this is the general tab, will give you the physical table mapping. The logical table is having mapping with the physical table, this physical table, SH physical table, SH schema, fact sales physical table. In the same way, logical columns are mapping with the physical table, physical columns. Okay, now how you are trying to do the mapping for this total sales from the physical to using the physical column mapping. You can able to select the expression here. So you are able to do the calculation like this. Amount sold multiplied by the quantity sold. Click OK. This is physical column mappings. Click OK. See, you can able to see the formula for this fact sales amount sold multiplied by fact sales quantity sold. These are the physical columns, not the logical columns. If these are the logical columns, what you can see the sum of amount sold multiplied by sum of quantity sold, because we have already defined the aggregation rule here. These are the logical columns, and you can see the formula for these logical columns as sum of amount sold, a sum of quantity sold. If it is so, now we have defined the formula for this new logical column from the physical column mappings, derived from physical mappings. Okay, let us drag and drop it into the presentation layer, because we newly created, right? So we need to drag and drop it. No, reload server metadata. and let us add it to the analysis results. See here, because of this total sales column is not defined any aggregation rule, and it is falling into the detail manner. The detail data is showing up on this particular day. These are the transactions are happened, and you can see 14 plus 7 is showing up the cumulative sales. Okay, so this is how the total sales column can be calculated. This is physical amount sold and physical quantity sold multiplied, and then you can see the sales here. And there is no aggregation rule defined here, so that you are able to see the data in a detailed manner. Now we can define the formula for the same column deriving from the existing logical columns. So deriving a formula for this new logical column using the existing logical columns. So what are the existing logical columns? We can browse it from the expression builder. This is expression builder. So here the category is logical tables category. Logical tables, what we have, fact sales logical table, and what are the columns? Logical columns we have amount sold, add it, multiply with quantity sold, add it, click OK. See here the formula amount sold column aggregated with amount sold and quantity sold aggregated quantity sold. That means aggregation rule defined on this amount sold column. So if you use the aggregated columns in the logical expression, this is a logical column expression. You are defining a formula for the new logical column using the existing logical columns. Then the formula for this, then what will happen is, if these logical columns are already aggregated, the same rule can be applied to this new logical column as well. See, these are already aggregated. Amount sold is aggregated to sum. This is aggregated to sum. The same properties can be followed to the new logical column as well. You can see that under the here, sum of amount sold multiplied by sum of quantity sold. Because these two are already defined aggregation rule, the same property can be inherited to this new logical column as well. So this is the difference between creating a formula for the new logical column from the existing column mappings and using the physical column mappings. If you use the physical column mappings, it uses the physical layer columns. When you define the formula from the existing logical columns, it uses the formula which is the columns of logical columns. Click OK. Save it. New logical column. Now reload the server metadata. And refresh the analysis. Now it will give you the aggregated results. On this particular day, amount sold is this much, and the quantity sold is multiplied quantity sold value is this much. So you are creating a new logical column in two different ways. One is physical column mappings, and other one is new logical columns using the existing logical columns. This is how we can create the new logical columns. Now I'm going to move on to the next concept, creating a time dimension hierarchies. Okay, to create a dimension hierarchy, what is the hierarchy and why we create this? Hierarchies are useful to the end users to drill down or drill up and to do the analysis on the level based and level by level they can able to do the analysis. They will go to the top level. For example, if you can take the customer wanted to do the analysis on the world wise, so you can able to give a world wise hierarchy or geographical hierarchy. So there we can able to give continent wise. Asian continent, what is the sales in the Asian continent, we have different countries, China, India, Japan. So we can able to Malaysia, Singapore. We can able to customer can able to drill down from countries to from continent to countries. Countries we have different countries. In the countries also we have different counties. So we can in the China or Indian country, India country, if you drill down, you can able to go to the different states, and in each state you can able to drill down to the states to districts or counties. So this type of analysis customer can able to do on a single entity by drilling down to the different levels. So to create these hierarchies, right click on the business model folder, new object, logical dimension with level based hierarchy. So we have different types of dimension hierarchies. We have one is level based hierarchy and parent child hierarchy. The level based hierarchy, when we create, it has again three different types of hierarchies: a normal level based hierarchy, a time dimension hierarchy, and skipped and dragged level hierarchies. Okay, now let us learn the level based hierarchy, which is having different levels, and then we can move on to the time dimension hierarchies. First, let me create a 0 1 time hierarchy. Click OK. That's it. This is normal level based hierarchy. Right click on that, new object, logical level. Level as grand total is the default level. This is optional. If you want to create it, you can create it. Grand total level, and define checkbox. Check this checkbox. This is a grand total level, and then you can create the child level as year. Year to quarter, quarter to month, month to week or day detail. Year level to quarter level. In the requirement document, they will specify this hierarchy details. So year level, quarter level, and month level, and we have day detail level. Just simply add day. This is a detail level. Okay, we have created the hierarchy, and then we have defined the different levels: year to quarter, quarter to month, month to day. So now once we define the hierarchy and define the levels, we need to add the members to these levels. Members are nothing but the logical columns. And which dimension you are creating this hierarchy, from the dimension to add the columns to this hierarchy. Okay, expand this hierarchy time dimension table, add the columns here. Calendar year going to add to the year level. Let's say quarter description going to add to the quarter level. Is it drag and drop here, or else copy it and paste. The same way month description, drag and drop it or copy it and paste it. And the day name. So I just created the hierarchy, defined the levels. Levels, how I define, right click on the level and define, create a child level. So calendar year is a member. I just added the corresponding columns as a members to these levels. And once I added the columns, I need to define the new logical level keys. New logical level keys can be created by right clicking on the level member, new logical level key. Click OK. Right click on the member, new logical level key. Click OK. The same thing here. For all the level members, you need to select the new logical level key. Once you add the members to the levels, right click on the member and new logical level key. That's it. You are done the creation of hierarchy. Just drag and drop it onto the presentation layer corresponding dimension. Excuse me. and save the repository. See, we do not have any errors or warnings at the moment. We have created a hierarchy, defined the levels, and added the members and define the new logical key. So only 3 steps: create hierarchy, define the levels, define the members, and define the new logical level key, and reload server metadata to test this hierarchy. Okay, now the server metadata data can reload it, and let me remove these things. Let me add the hierarchy into this analysis. Here is the hierarchy. Drag and drop it or double click on it, and the amount sold results. Grand total we have. Just expand this grand total. We will be drilled down to the next level, that is year level. So in this year, these are the yearly wise sales. When you sum up all these year sales, that will be equal to the grand total level. All the year sales will be equal to the grand total level. When you expand the 1999 year, you are able to go to the 4 quarters of the 1999. When you sum up all these 4 quarter sales, that will be equal to the yearly sales. That is level based hierarchy. Whereas compared to the parent child hierarchy, that is vice versa, because the parent child hierarchy example is, you have an organization where we have a project manager and some number 10 member of team members, and when you compare the sales of in a hierarchical manner, if you see the hierarchical manner, parent is the manager and childs will be members, team members. But when you sum up the salaries of the team members, that will not be equal to the project manager salary. So that is different. That is parent-child hierarchy, and there will be a parent and this different member keys. And when you sum up all these sales of these members, that will be not equal to the parent sales. Whereas in the level-based hierarchy, it is when you sum up the sales of members, that will be equal to the parent sales. And you can drill down to the month level. And month 2, in this quarter we have 3 months, and in the month we have 31 days, 30 days, and every day wise sales. If you add time ID column, primary key column, then you can see the 31 days sales. Now this is how we can able to drill down using these hierarchies. And now I'm going to create a time dimension hierarchy. So to create a time dimension hierarchy, you need to have a valid time dimension table in your logical layer, and then for the hierarchy you need to select this checkbox, time checkbox. Whenever you select the checkbox, time checkbox for the time dimension hierarchy, it needs to follow additionally 2 more rules which we have done up to now. Up to now we have created this hierarchy, right? For this normal hierarchy, additionally 2 more rules to be followed. Rule number 1 is each level should be defined with a chronological keys. Level properties, go to keys tab, chronological key, click OK. In the same way, each level properties, it is optional. Either one level of the hierarchy should be defined as a chronological key. I am defining for all the levels as chronological key. And I would like to add the primary key column of this dimension as a member to this time ID, copy, paste. What I'm doing is I'm just adding time ID column as a member to the day detail level. I'm defining it as a new logical key. Why I'm adding it is the second rule is for the time dimension hierarchy. For second rule is the detail level should have the primary key column of the dimension table. In a time dimension hierarchy, if it should be a time dimension hierarchy, a valid time dimension hierarchy, it should have the chronological key defined. Why do we create chronological key and what is chronological key? Chronological key is a key column for the level, and it will uniquely identify the data. It will uniquely identify the unique data can be identified by this chronological key. And in this level, year level, we have calendar year column. If we have duplicate records in this, what it is, this chronological key column will do is unique data can be identified from this level when you define a chronological key. And this is useful, this time dimension hierarchy is useful to work with the time series functions. There are some set of time series function which we are going to discuss going forward, and to work with this we can need to a valid time dimension hierarchy created in your logical business model. And I have added the primary key column and define the chronological key for this detail level as time ID. One of the columns should be defined as chronological key. So additionally, what we are doing here to the normal level based hierarchy, additionally what are we doing? Additionally what we are doing is we are simply creating the chronological key to uniquely identify the members in the data members in the level. We just added the chronological key. Go to the level properties and keys tab and scroll to the right side. There you have a chronological key. Select it and click OK and define it for all the levels. And another step what we did here is added the primary key column of the time dimension table in the detail level. The detail level should contain the primary key column of the dimension table. That is additional rule. So these two additional rules to be followed to the normal level based hierarchy to create a time dimension hierarchy. So let us reload the server metadata. The functionality will be same. The functionality, how it is working with the normal level based hierarchy and the time dimension, when you check the time check box, how it is working, and without checking the time check box, how it is working, the functionality will be same. But when you select the time check box, we need to follow additional two more rules. And why do we select the time check box is to have a valid time dimension hierarchy in your logical business model to work with the time series functions. The same functionality it will follow. Okay, how to work with the time series functions and what are the time series functions? Okay, time series functions are useful to roll back, or if you want to compare the sales from current sales to previous 3 months sales or previous 3 years sales. And if you want to compare the sales from current year sales to next target sales, in the next quarter you have this much of target sales. So if you want to compare current sales and up to date MTD sales, EGO sales or to date sales, or if you want to compare the period rolling, there is a function called period rolling. If you want to compare the sales between some particular period of time, you can able to go with use this automatic default time series functions. Okay, to create a time series function, to work with the time series function, let me create a new logical column. Okay, new logical column is year ago. Let us assume that, and this formula for this new logical column I'm going to derive from the existing logical columns. The formula is I'm going to define it as functions category, time series functions, ago function, add it, and it has three arguments. One is measure column. So measure column can be a logical tables, fact sales table, amount sold. I'm going to add the amount sold as the measure column. Level, which level you are going to look into. The levels can be added from the time dimensions category, time dimension, year as the level. Add it. number of periods, how many years you want to go back. Ago is nothing but going back. So how many years you want to go? 1 year. Just for this moment, at this moment I'm just selecting one as number of periods. Click OK. So ago function gets created and it has three arguments. One is measure column, level, to which level you are going to compare the sales, and how many periods you want to compare. That is 1 year. Click OK. If any error message in your syntax, it will not allow you to close this window. Formula syntax, if you have any error message, it will not allow you to click on OK. Okay, ago function gets created. The same thing, I'm going to create the to date function as well. New logical column, YTD, AMT sold. Amount sold, year to date function. I'm just using functions category, time series functions, to date function. And this to date function will have two arguments. And argument one is measure column and level. The measure column can be fact sales, amount sold, and the level is nothing but the hierarchy. Time dimension hierarchy, level is year level. You can able to add any level, year, quarter, month, or date. You can able to add any level. This depends on the comparison you are doing in the reporting end. To date function gets created, and I'm going to create another function for period rolling. Okay. PR, period rolling, amount sold. Column source, derive existing columns, functions category, period rolling, add it, measure column to be selected from the logical tables, fact sales, amount sold, and starting period offset and ending period offset. Starting period offset is nothing but from where you want to start and from where you want to end the period. Which period you want to compare the sales. The starting period's offset can be 0. 0 is nothing but, for example, if you doing the analysis on the monthly basis, just assume that you're doing the analysis on the monthly basis. Current month is 0. 0 is the current month. And ending period, if you want to compare to the next 3 months, current month, and next month, that is 2. That is October, November, October as 0, November as 1, December as 2. So this expression will compare the monthly sales of amount sold for the October, November, and December only. For example, if the starting period is -1, then what will happen is it will compare the sales of September, October, November, December. -1, 0, 1, 2. This is how we can able to define the starting period offset and ending period offset. So for example, if you define the starting period offset value as -1 and 0, then what is the month it is calculating is previous month and current month, that is September and October. So this is how we can able to define the offset values. 0 is the current month, and if you define the minus, negative values will be go back and positive values will be coming months. Let us say 3 months. So I'm comparing the totally 3 months here. 0, 1, 2. 0 is current month, 1 is next month, 2 is December. Clear, right? This one is clear, right? So these are the 3 different columns we have created, and let us drag and drop it into the presentation layer. Save it. Now need to check the consistency and reload the server metadata. Once you see the results, it will be very clear for you. Okay, now the column is created, right? So let me add a new analysis. I will show you the differences between each of them. I'm going to add the calendar year column. Amount sold, year ago amount sold. See the results here. Excuse me. See here, amount sold value for the 1998 is this one. And in the repository for the year ago amount sold, what we are doing just go and verify the previous year sales. Previous year sales only you are getting. Year ago is nothing but going to back. Amount sold year level, go back 1 year back. That is what it is doing here. 1998, this is the amount sold actual value. But for the 1998, what is the previous year? 1997. For the 1997, we don't have any data. That's why it is displaying null value or empty value. And for the 1999, this is the amount sold. And for the 1999, year ago amount sold is what? 1998 sales is the previous year sales. 1999 previous year is 1998 and its sales is 24 and the same value is 24 millions it is showing here. The same way for the 2000, this much is actual value. For 2000 previous year is 1999. So 1999 sales will be displayed as year ago sales for 2000. That means it is going back ago sales. I hope it is understand. If you have any questions, you can just ask me. And YTD amount sold. Just click on the results. YTD, that is nothing but to date. To date function we have used in this YTD. Today's is what? Year to date. Year to date. That means starting from the January 1st, 2015 up to 31st October. Starting from the January 1st, 2015 up to date, what are the sales we have? That is year to date. But yearly sales is what? The whole completed year sales. That is January 1st to December 31st. What are the sales comes under? That is whole year sales. Year to date, nothing but from the starting of the year to up to now for today's date. What are the sales? That is comes under the to date. And here you can see the sales for the year 1998. These are the sales, and for the year 1998, these are the same value displaying for YTD amount sold. Why? Because the year is completed already. If we have the ongoing transactions or ongoing business, then it will be very clear to understand this to date sales. So every business has its own target value. For this year, we have to reach this much of target revenue, and they will intermediately after 6 months or 8 months they will go and log into the application and will compare the YTD value, whether they are about to talk what is the actual value and what is the YTD actual value and what is the YTD what is the yearly target value. Actual and target they will compare, and they will able to identify what are the initiations they have to do, what are the areas they have to improve. So this way, whether they are reaching to the target value or not, this way they can able to do the analysis. Here all these are the completed years. That's why the same value is displaying here. And the next measure is period rolling. results. Okay, if we can see here, yearly basis, this is the 1998 years. For this 1998 year, what it is showing is current year sales, next year sales, and next 10 year sales. When you sum up these three values, value will be this one. When you sum up these three values, values will be this one. When you sum up these two values, because we don't have data for 2002, so this is the value. So for 2001, 2001 year sales, 2002 year sales, 2003 year sales. So we don't have data for 2002 and 2003. So it is summing up only the data available. So the same value it is displayed. So that is period rolling from starting year to next year and next year, because 0, 1, 2. So we have defined three arguments there. So three values there: 0, 1, 2, 0 to 2. Between that 0, 1 and 2. So totally 3 years. If you can compare it with yearly basis. So when you drill down, it will do the comparison on quarterly basis. So for the first quarter, we have this is the amount, and period rolling amounts. So what it is doing is quarter 1, quarter 2, and quarter 3. 0, 1, 2. Starting period offset value is 0 and 1, and ending period offset value is 2. So it will sum up these three records and display it as one record here. The same thing, if you drill down to the quarter to month, it will do the calculation on monthly level. So for the first month, this is the sales. Second month, third month. Some of these three values will be period roll amount sold, and some of these three values will be period rolling amount sold. And if you drill down to the day detail, it will be very clear. Excuse me. Let me get. Okay. That is how actually we are able to understand the period rolling functions and period function and go function. If you have any questions on this time series functions, you can ask me now. These are important in terms of interview perspective. And the next concept is level-based measures. You can able to add, you can able to restrict the one of the column execution to particular level of granularity. That means we have time dimension, right? So in this, if you add quantity sold as quarter level, if you add quantity sold into the quarter level, click as checkout. So this quantity sold added into the quarter level. Otherwise, simply go to the measure column properties and levels tab, time dimension hierarchy, select the level here. Click OK. That means what is happening is this measure column is adding into the particular level. So when we add any measure column to the particular level, what will happen is the data of that particular measure column will be restricted to display up to that level only. the data display for this particular measure column quantity sold restricted up to display only quarter level. It will not display the data for month and detail level. That is level based measure. What is level based measure is you are putting a restriction on the column data to display up to this level only. By adding that column to the level, you simply add that level column to the level, automatically it will restrict the data up to that level only. Check the consistency. There are no errors or warnings at this moment. And now let us go to and test this level based measure. And you can see the results for the day detail. So Friday we have, Monday we have this amount of sales. When you sum up these three values, that will be equal to this one, 15, 28 millions. So this way we can able to populate different values for this. And now I'm going to create the analysis. Before that, reload server metadata as we did the changes in online mode. And server metadata once reloaded, excuse me. Here you can just add the hierarchy. Let us hierarchy and quantity sold column. Results. See, for the grand total value, it is not showing any value. When you drill down also, it will go to the year level. So in the year level, it is not showing any value. When you go to the quarter level, from the year to quarter level, it is showing data. And when you go to quarter to month, the same value is repeating. The same value which is having for the quarter, the same value is repeating for all months. And in the month level, if you drill down, the same value will be shown. See, that is level based measure. That means you are restricting that, you are sticking that level value, that measure value to that level only. For this quarter, what are the sales we have, the same value stick to this level only. In other words, you can also do the analysis on the column basis. See, now it is displaying the, we have year only, but in the year how many records we have? In the child level of the year, how many values we have is 4 quarters in the year. So quarter 1, this much is the value, quarter 2, this is the value, quarter 3, this is the value, and quarter 4, this is the value. So it is showing it in the quarter base only. Even though you added the year level, year column, it is showing the data in a quarterly basis. Now you can see this. Even though you drill down to the next level, it is showing up the data in quarter level. Even though now you also, it will show the quarter data. So that measure column data is restricted to display up to quarter level. That is level based measure. And the other one is aggregation content. So you define the aggregation on the particular measure value to restrict that, you are restricting the quantity sold value to display up to quarter level. Now what I am going to do is, instead of one particular column in the table to restrict the value of data display, I want to restrict the whole table data to be restricted to particular level. That means the whole table data will be aggregated and it will display to the particular level only. For that, simply go to the logical table properties, LTS properties, content tab. Here we have to define the aggregation content group by which level. The logical level is 0 time dimension hierarchy, and the level is, let us say, quarter level again. And click OK. Now what will happen is the whole table data can be restricted to display up to quarter level only. See this. So warnings can be ignored. If any errors, we can able to take a look into that. Reload server metadata. Now what we are doing is the whole fact sales table we are aggregated to the quarter level. Define the aggregation rule of the fact table. Then what will happen is if any column from the fact table you use, there is a group by class added, and the group by class you can see the calendar quarter description column. Let me add a calendar year, amount sold. The amounts will be added from the fact sales table. So now it is displaying the data for all the years. Drill down, quarterly display the data. Now you drill down from the quarter to next level, gives an error message. So actually what will happen in this aggregate navigation is up to quarter level it is displaying the data from the aggregate table. This is aggregated table. If you add another LTS which is having detailed data, then what you can do is simply go to that LTS properties, detailed LTS properties. Just assume that this is a detailed LTS, and here you can able to select it as detail. Up to quarter it will go to the LTS1. From there it will go to the LTS2 which is having the detailed data. Then you will not able to see the any error messages because of we do not have any detailed data, detailed LTS. That's why it is showing up error. Up to quarter level only you have you are putting restriction for this LTS. So that is aggregate navigation. Up to quarter level go to the LTS1, and if it is LTS, if you have an LTS2 you can able to define it as a detail level, so that it will go to the next level. Now I defined it as detail level, and now you can see data is going to the next level as well. Reload server metadata. Refresh this analysis. Now you can see the data, right? No error here. Now drill down from month to day detail. So that is how this aggregate navigation will work, and this is an important one. And there is another option. Yeah, there is another option we have here is for the logical table source we have a where clause filter. So here you can able to pass a condition. What condition is? For example, if you want to put a restriction on the records to be populated from the repository, you can able to put a restriction to the data in the repository by applying a filter to the logical table source. So from this table, for example, go to the dimension table, uh, countries, country sources, dim countries. If you can add a condition here, condition can be country name is equals to, you can able to give one condition, the country name is equals to India or United States of America. You can give the value of the country name. So from this table all the time you are able to only get this data only this country name data only. So this is global filter. In the repository you are able to put a restriction on the data by applying filters in the logical table source where clause filter. So that is it. And tomorrow we are going to discuss about the rest of the concept like variables in the repository, and then the object level, data level securities, and the creating the reports, dashboards, and creating the agents, action links, different things we will see in the tomorrow session. You have any questions in today's session? Just we can ask me now. Ask me now.
No question from my side.
Okay. Thank you.
Even me too.
Any questions, Vinod and Funny?
No.
Okay. Okay.
Srini, will there be any materials which will be shared?
Yeah, I will share this recording video as well as some development material for this repository building and report building. I will share the material as well.
Okay.
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 Yeah. Yeah. Thank you.
Thank you.
Yeah, thank you.
Yeah. Bye. We'll catch up tomorrow same time.
Yeah, sure.